Course 3, Lesson 27, we are looking at laws of exponents. So being able to simplify exponential expressions involving factors and using our laws of exponents. So our first law of exponent is if we are multiplying together powers that have the same base, we can add the exponents. So if they have the same base, like in this case we have 4 to the third times 4 to the ninth, those 4's are our base, so we are able to add the exponents. So in this case we can say this is the same thing as 4 to the 12th. Now we keep the base the same. We don't say that our base is now 16. We keep the base the same, and that's because this 4 to the third we can describe as 4 times 4 times 4, right? That's our original form. And then we can multiply that by our 4 to the ninth, which means we are going to multiply by 9 more 4's. Let me get them all on here. Which means if we see all of these, our base is still going to be 4. And instead of saying that I have 3 and then another 9, I can just say that I have a total of 12 multiplied together. For our second example, 9 to the third times 2 to the ninth, it might be easy to say, oh, this is 18 to the 12th. But in this case, we don't have the same base. 9 is not the same as 2, so we couldn't say 9 times 9 times 9 times 2 times 2 times 2 times 2 times 2, all of these 2's. We couldn't simplify this any more than it already is. We could multiply the numbers together, of course, and get one big number, but we can't make it any simpler with exponents. They don't have the same base, so we are not allowed to add the exponents. Second rule, if we are dividing powers with the same base, we can subtract the bottom exponent from the top exponent. So if we have our same base, like these 4's, 4 to the ninth divided by 4 to the third, we would say 4 to the 9 minus 3, so that's 4 to the 6th. Well, what we are saying is that I have all of these 4's, 4 to the ninth. Okay, and I'm dividing by 3 4's. Well, we can see that we have some pairs that we could say, okay, 4 divided by 4, that's just 1. Another 4 divided by 4, and another 4 divided by 4. Which means we cancel it out, everything on the bottom, and we really just have these 6 4's multiplied together on the top. So we would say our answer is 4 to the 6th. Similarly, we could say, all right, 9 to the ninth divided by 4 to the third. Well, maybe it would be tempting to say, maybe that's 5 to the 6th because I'm subtracting. But once again, just like on the other page, we don't have the same base, so we can't simplify anymore. Yes, we could get a big long number, but we can't simplify the exponents and get an exponential answer. So let's practice a little bit. If we have 8 to the third times 8 to the 7th, we would say that's 8 to the 3 plus 7, or 8 to the 10th. Remember, if we're multiplying things with the same base, we are allowed to add the exponents. If we're dividing things with the same base, we would do 3 to the 5 minus 3, which is 3 squared. X to the 5th times x to the third, we can add those exponents and get x to the 8th. And then dividing x to the 5th and x squared, we subtract and get x to the 5 minus 2, which is x to the third. Okay, so remember, when we are multiplying things with the same base, we add the exponents. When we're dividing with the same base, we take the numerator and subtract the denominator. Our last rule is with a power to a power. What we're saying is we have something like this, x squared, and then we are saying I want 6 of those multiplied together. So x squared to the 6th power, which would be something like x squared times x squared, all of these x squareds. Well, if you saw it like this, we're multiplying, so we would just add the exponents. So I'd say I have x squared or x2 plus 2 plus 2. Okay, all of these 2's added together. Well, isn't multiplication just repeated addition? I could just say this is x to the 2 times 6 because I have 6 2's. Well, that's just x to the 12th. When we are taking a power to a power, we can multiply, Because really what we're saying is I just have repeated addition right here. So with our a to the 5th to the 8th, that's just a to the 40th. So a power to a power, you multiply. Okay. So we have these 3 rules. Make sure that you know what these are. Here's a couple more examples of them. If we're multiplying powers, we add. Dividing powers, we subtract. Power to a power, we multiply. These will help you do more complicated things. So let's say we have something like this. X to the 3rd times x to the 5th divided by x squared. Well, let's figure out that numerator. We're multiplying, so we add. So x to the 8th divided by x squared. Well, now we're dividing, so we subtract and get x to the 6th. Or maybe we have one big long multiplication, like 3 times a squared times b times 6b cubed a to the 6th. Sure. I can rearrange this because everything is just multiplied. So I can say, all right, I'm going to multiply the 3 times the 6, and I'll multiply the a's together because those have the same base, and I'll multiply the b's together because they have the same base. So 3 times 6 is 18. A squared times a to the 6, well, we can add those together and get a to the 8th. B, well, that b has an exponent of 1, so b times b to the 3rd I add and get b to the 4th. Or maybe you try this one. Y squared divided by y to the 5th. Well, remember when we're dividing we subtract, so we could say y to the 2 minus 3. Or sorry, 2 minus 5. And when we do that, we get y to the negative 3rd. Soon, we will figure out a way to get rid of those negative exponents because in math, we don't really like to work with the negative exponents. So soon, we will figure out a way to get rid of those as well. Well, I hope this is helpful for your homework and for studying.